good morning, good afternoon, good evening, wherever you are. Today's webinar, number 18, we have Andrzej Zwierzchowski. I tried to practice this with Andrzej, but I probably need to practice it a little bit more. But I'm very happy you're on the show, Andrzej. I saw this presentation at Directions and I found it very worthwhile to be shared. An even bigger audience than you had in the room. I think there was quite a number of people there. And today we've got another audience, and of course this is recorded, so there will be many more people. So today Andrzej will talk about automated code refactoring. What I recall from your presentation, that there were parts really, I mean, a lot of experience from you in any way, but what we profit from your VS Code extension AZ development tool, there's a lot of things in common in what you're telling here, but of course the purpose is a little bit different. But I'll leave it to you, of course, to dive into it and to introduce yourself a little bit more. As always, housekeeping rules. Feel free to interact by using the GoToWebinar question window as your microphone is muted and stays muted. On the audience side, of course, I, Luc van Vugt, today's moderator, will pick up your question, and we agreed we will pile them up till the end. So Andrzej will tell his story, and then after 45 minutes we'll have the Q&A. So feel free to feed it. It might be that your question is answered by one of the slides. I will already point that out to you, and maybe you then still have a question or a more specific question to it. So be welcome to do that. And like always, the recording is running, and after this session somewhere this evening I will do my best to get it processed and get it on YouTube so you can use it, share it, replay it for whatever needs you have. Didn't you subscribe to our newsletters? Please do so. As you will see on the next slide, and let's jump into that, there are a couple of more sessions ahead. As you can see, 3 have a clear title. 2 of them, the one by David Singleton and Camille, will be in the newsletter that's going out somewhere this week, hopefully tomorrow. The other 2 by Arend-Jan and Patrick, I need to get their title and abstract still, and then that will be also available for registration. So the one on February 5 by Stefano De Miliani, there is a registration link already on the website. Oh yeah, on the website I also shared the link for Camille's session. David Singleton's, there was an error in the text, and we needed to get that fixed first, but know that when you're subscribed to the newsletter, and if you didn't do that, so you'll get the information on when this happened. So always looking for new speakers. As you can see, some familiar names here, reappearing names, new names. Patrick Schiffer will pick up a session. I'm very pleased to have him on the show, like anybody else, but it's good to have new people stepping in. So if you want to be one, let me know. And before Andrzej, I'm going to hand over to you. Thanks to Fornaf to enable us to do this. So I'm going to make you presenter, and then you would be able to share your screen. So, yeah.
Thank you.
Yeah.
Good. Welcome everybody to this webinar, to this session, where I will be talking about the automated code refactoring. And how you can benefit from it. So yeah, so let's just start. First, a bit about me, so you know who is speaking. So my name is Andrzej Zwierzchowski. I'm working as a development standards lead at enough people when I'm looking at our development standards and helping our developers to work with AL or with DevOps or with Git. I've been awarded Microsoft MVP award this year or last year, and I'm also a developer, so I work with the AL, I work with Cal in past, And I'm also using C# and JavaScript and TypeScript. So I'm trying to look at the different technologies. And as Luc mentioned, I'm also the creator of AZAL DevTools extensions for VS Code that you can use when you develop your AL projects. Yeah, also on this screen, as you can see, I have the GitHub account where you can see the source code of this extension and some other bits. That's also where you can, if something is wrong, that's where you can post any issues that you have with this extension. Also, I have a Twitter account and a blog, but I haven't updated the blog recently. Probably I should, but I'm more focusing on, obviously, helping with the extension. So let's talk about the automatic code refactoring or automatic code modifications. Yeah, why you might want to do it and when you might want to do it. So why? Yeah, you might have a situation where you have old code that you need to upgrade, and you need to change a lot, and you decide that first maybe you want to change something, and also maybe something is not working because something has changed in the extensions that we are referencing, and you need to change a lot of places, but those changes seems to be repeatable. You can see a pattern. So instead of typing it manually, maybe instead of changing it in a few thousands or a few hundred places, you are thinking, can I just write quickly something that will help me with this code? Yeah. So when you're upgrading code. Another situation when you may want to do it, when you want to improve quality. You can see that there is some bad pattern in the project, and again it repeats in multiple places. So you're thinking, can I automatically just run through it, find those places and fix them? And also maybe you have some simple rules, you have some simple changes. Maybe there are some repeatable tasks that you expect people to be doing in the code, but as I said, they are simple, they're repeatable, and maybe you want to automate them, instead of just making sure that everybody just writes it and follows some rules. You may say, okay, you don't have to do it. We will just run some tools, and they will do that for those things for us. So that's why you may want us to have this automatic code refactoring or modifications. And then another question is when you want to do it. You may want to do it manually during development. So it could be a tool that you run yourself, command line application, just run it and it's doing something for you. Or maybe you write something that you just run once because you are upgrading old solutions. So just write something once, run it once, and just delete those scripts or those software, and you have the code updated. Maybe you want to do automatically on the file save. Obviously, then it means that you probably need to build the extensions for VS Code to run it automatically when you're saving the file. That would be a bit more complex task, which I'm not going to cover. I'm just telling that you can. You can have even a command line tool that will be run when you save your files in VS Code. Or another idea when you could run it would be automatically from DevOps, which I don't think that is a good idea, but I saw people asking for it. I don't think that is a good idea because you have a situation where you're writing your code, you're testing your code, you think that everything is fine, you finish the task, that feature that you've been asked to implement is ready, and then you commit to your branch, and then let's say you're creating pull request to one of your main branches, and at this moment DevOps starts, and if you start modifying the code at this moment, then it means that the code that gets to those main branches is not the one that you tested. So it's a bit uncomfortable, yeah? So you write the code, you test it, and that's not what ends up in the main branch. And if there is a bug, that you're taking this code, you're fixing it, and then you want to push it back, and DevOps starts again, and it's again not the code that you really tested. So there's this idea here. You should be very careful with it. Yeah, it's sometimes, okay, I understand that it could make sense, but I also feel that it's a bit dangerous. Okay, so AL source code, how you can create it and how you can modify it, how you can automate it. So if you want to create a new code, you can obviously use AI. This is a hot topic now. And you can use ChatGPT, you can use GitHub Copilot, whatever you want. But that's not what I'm going to cover here. Yeah? And with AI, it's, yes, you can use it, but you should verify it, because you never know what you will get. Yeah? And every time you ask, you can get different results for the same question. Another option how to create new code is you can just write it directly. Yeah, so write some script that just writes the code to the file, just writing to the output, just concatenating the strings. And if it's a new code, I would say that would be the way to go, because it's very easy to write. But that's also not something that I'm going to cover here. And the last option for creating a new code would be to use AL compiler. AL compiler gives us a libraries that we can use for doing that. And it means that you have to write your code in C#. And then what about modifying the code? Again, you can use AI, but again, just make sure that you verify the results. You have to check it. Another option is, if it's something simple, you can use regular expression and just modify the text. As I said, if it's simple. And also, that's not something that I'm going to cover here. Another option would be to just write your own AL parser and parse the text yourself and then modify it. But that seems like a complex software that you would have to write. And the last option is use AL compiler. Again, you will have to use C# to do it, but it will allow you to get the code, modify the code, and write it back. So that's how you can modify it. And for me, what I'm going to cover will be obviously the AL compiler, the AL compiler libraries, and I want to show you how you can use them to change your code. So let's talk about AL compiler. But just before I start talking about AL compiler, remember that it is unsupported. So there's no support from Microsoft for using AL compiler libraries, and it's undocumented. So again, don't be surprised. Don't look for support. Don't look for documentation for the AL compiler. But it's not so bad because the AL compiler is based on Roslyn. Roslyn is a .NET compiler platform. It's a compiler for C# and for Visual Basic. It's open source. You can find the source code for all this platform, for all those libraries, and there is a lot of documentation. And here is the link on the screen. That's where you can find the documentation for Roslyn compiler. And the good thing is that the concepts are the same. Many of the APIs, functionalities are exactly the same. And the differences are in the parsing, obviously, because the structure of AL is different than the structure of C#. But the concepts, the way you use those libraries, it is basically the same. So if you need to find some information, you need to understand the concept, how to do something, then C# documentation should be enough to guide you, to allow you to find the solution. Okay, so let's talk more about this AL compiler. So AL compiler, it's not only just a compiler. This is a set of .NET libraries. Yes, there is a command line compiler that can compile your project, but also there are libraries that allows you to analyze your code, to modify your code, to check it, to build it. And there is one very important concept in those libraries, in the way you can use those classes, those objects from the compiler. So the basics of it is that all the structures that you're getting from the compiler are immutable. And what it means, it's the concept where any data structure that you are creating is read-only, which is thread safe, so allows you to use the same data with multiple threads because they are read-only, so you don't have to build any locking mechanism into your software because one thread might modify your structure, so the rest needs wait. No, it's nothing like that here because nothing can change. Yeah, so you can have solution that analyze those immutable data structures on multiple threads, which then is faster. But you might still say, but I might want to modify sometimes those structures. And in such a case, if you need to modify something, it means that you need to create a new structure. And then that new structure can again be used as a read-only set of objects and data. So every modification returns a new object. So sometimes you may see a list there with, for example, add method. But this add method won't add elements to the list. It will return you a new list with the new list of elements. So if you have a list of 10 elements and you add another one, what you will get, you'll get another list where that 10 elements from the original list are copied and added there, and the or maybe not copied, they're added also to your new list, and your 11th element is added at the end. So don't be surprised, yeah, that just you write a method, you call a method add, and nothing is added to the list. No, a new list has been created. So as you can imagine, it can be quite memory intensive if you write a lot of modifications because you are constantly creating copies of those whole structures. Okay. So still AL compiler and still basics of the compiler. So what compiler can give you, or what compiler is using? The compiler is using syntax trees. So when compiler parses and source code, or when you are using compiler libraries to create source code, to create a code, you're basically using syntax trees. You're building syntax trees, or you're getting syntax trees from your source code. And syntax trees, they contain nodes, syntax nodes, and then those syntax nodes are built from another syntax nodes, or at the end of this, you have tokens, language, and those are the language elements that you have in those structures. So it's a big tree. And syntax trees are generated per file. So for each file, you have a separate syntax tree. But those syntax trees, they don't know anything about other syntax trees. So it only parses a file, it splits it into the language elements, but it's not checking if this code makes sense. It only checks if, from the language point of view, if the syntax is okay. So you may have like the declared variable of the record type of the table, and then you will have a table name there, but it doesn't mean that this table exists. Yeah, so syntax tree can be valid, can be okay, but your solution may not have this table. And at this moment, at this level, you don't know about it. Everything looks okay, everything looks fine, but you don't have this information that this is the record, this is the table, this table has those fields and those procedures. No, you don't see it on the syntax tree level. Yeah, you don't know. And there is also another part of this syntax trees, which is called trivias. And trivias is something that is attached to the nodes, but it's not part of the language itself. It could be a comment, it could be a space, white space, it could be new line. Also, compiler directives are those trivias, and they are usually attached to the next syntax token that is just after these trivias, which has interesting consequences, because if you remove a node from the syntax tree, like syntax node, and there was a trivia attached to it, then this trivia will also disappear because it was part of this attribute of the node. So you can imagine that you have the procedure, and above the procedure you have region, which region is trivia. And then at the next procedure, you have trivia, which is, under the procedure you have end region, but this end region is attached to the next procedure because that's the next token below it. So if you reorder the procedures, then the trivia will go together with the procedure, and then you may have end region first at the top and start region below, because they are just attached to the procedure that is just behind it. So be careful. And if you want to know more about the syntax tree, here's the link at the bottom. That's where you can read more about syntax tree, how to handle it in C#. Yeah, so it's for C#, but really matches our AL case perfectly. So you can look here. Okay, a bit more about compiler again. The parser. So the libraries contain the parser that you can parse. You can use this parser to parse the source code and get a syntax tree. And to start using it, obviously you need to create a new project, C# project in Visual Studio, and you need to reference a few libraries from the compiler, from AL compiler. So you can find them if you go to your profile, to the VS Code, VS Code folder. There will be extensions folder, and inside will be the Microsoft extension. There will be bin folder, and in this bin folder, you can find those libraries. And what you need one library that you need is Microsoft Dynamics Nav Code Analysis.dll. That's where the parser is. That's where the syntax tree are defined. You will also need Microsoft Dynamics Nav Code Analysis Workspaces, DLL. That's where the project and solution workspaces are defined. It doesn't matter what it is. You need it because this library contains a function that allows you to format files, format your code. It helps, instead of generating badly formatted code, this one gives you nicely formatted with nice indentation file. So it's good to use it. But this formatter needs also the workspace, and this workspace, just parameter, there is a very nice workspace defined in another DLL, which is Microsoft Dynamics Nav Editor Services Protocol. So those three, if you add them to your solution, that will be enough, and then you can use it. Then how to create those nodes? Because, as I said, those structures, that the syntax tree elements are immutable. And you might think, okay, I will just create them by creating new objects, but that's not how you do it in those libraries. The concept here is there is one class called SyntaxFactory, and it has a lot of methods to create different types of nodes. And if you want to create those elements, those nodes, you should use this class and just start calling those methods. Like here, syntaxFactory.table, and it will create a table with ID 50,000 and the name, directions table. And then you can use with, and this with on the table, on the objects that are created, which allows you to modify the object, create copies with different elements inside replaced by something else. So if I call table.withFields and then pass the list of fields, then a new table will be created, and this table will have the same ID, the same name, but the list of fields will be replaced by the one that I'm passing here. That's how you can use it. But that was list of slides. Let's take a look at the demo. Let's take a look how we can really write the code that will create something for us. So let me just open the example and let's move it here. So I have a project here, very simple command line project. It has dependencies to those 3 libraries that I mentioned. And what I'm doing here, I'm creating first list of fields. So I have standard.NET list, and field syntax is the class from the libraries. And then I'm just creating first, populating this list. So I'm adding a new field, calling the SyntaxFactory.field, where I specify the field ID, the name of the field, and then the data type. And a data type, I'm creating data type using, again, SyntaxFactory. So SyntaxFactory.simple name data type. And then it also expects some parameters, so identifiers. So I'm passing identifier. As you can see, it's all from SyntaxFactory. And then I have one field, yeah? And then I'm adding another field to my list below. So this time is text, 250 character long. And then I'm creating a table here, like on this presentation slide. And then I'm adding my fields to the table. So creating a new table, but with the fields. So I'm calling table with fields. And here, again, SyntaxFactory that will convert my list to the field list. And then a bit of code that will nicely format me my my main node, the table node. And then I'm just converting this node to string and writing it on the screen to see how it works. So if I run it, let's just run it, and wait a moment. I hope that it will run on the right screen. If not, then I will move it. Okay, obviously on the wrong screen. So here it is. As you can see, here's the output. Yeah, table 50,000 and my 2 fields here. Yeah, they are here. So that's how you can create new. That's how you can create a new. Good. But we are not talking here about creating new objects. We are talking here about modifying existing objects. So how to do that? First, obviously, you need to parse the source code to have a syntax tree with all elements from this file. Then you can create new elements exactly in the same way as I showed you just in this previous example. Then you can add them somewhere to your syntax tree. Obviously, so it means that you have to go through your syntax tree, modify the elements. Once you're ready, you have to format your new syntax tree, convert text, and then save to a file. Replace the file that you just read, or maybe save it somewhere else. So that's how you can. That's how you can modify the code. But obviously, the question here is, you know what? Yes, I have a source code, but I have no idea what I'm looking for. I know what I want to modify, but then what should I do? How I can find those elements of the syntax tree? Is there any documentation? Yeah, how I can check it? So we have 2 options. One of the options would be to just parse the code and just use debugger and see what's there. Yeah, stop the debugger somewhere and just analyze the data, analyze what you have in the variables. But you can also use my extension in VS Code, yeah, AZLDevTools, and there is a command, open document syntax visualizer. And this command will open you a tree where you will see the syntax tree from the source code, so then you can see what is there. And once you know what is there, then you can think about writing your code. So let me show you that. Let me show you how you can modify the code, and also how you can analyze what you have inside. Let me just open the VS Code quickly, and let's open the example. So here is my code example, and let me also open the Visual Studio example for modifying VS Code. Okay, so here is the AL code, and if you want to see what is there, you can go here, and there is Open Document Syntax Visualizer. Here is the structure. So as you can see, the syntax tree first element is compilation unit. It has a list of objects, and there is just one object, which is a table. It has keyword. When I click here, the element, the syntax node is highlighted in the file. We have object ID, name, yeah, a list of properties, fields, yeah, and this is very interesting here. Look, when I select this field, that's where the field is. If I select the second one, look, it starts here. As you can see, this comment and the pragma is attached to this field. And then if I click on the last field, this pragma that is restoring what previous pragma disabled is attached to the next field. So if I use the parser and replace the nodes, change the order, then those pragmas will be moved together with the fields in this file because they are part of the field. So that's the visualizer. Now let's take a look at the source code. So let me quickly open the solution, and it will be here. So here is my example of the C# code that will modify my file. Yeah. So here we have the file, and here we have an example that will add another field. We want to add another field to our table, field 8000, which will with the name synchronization state. So what I'm doing here, I'm obviously reading source code, then I'm parsing source code, then I'm getting the root element, which is compilation unit. That's what I checked. And then I know that the first object was a table in this example, yeah, because I just checked it. And then I'm creating a new field. Then I'm creating a new list of fields by calling this add fields on the fields list of this table, which gives me a new list of fields. And then I'm creating a new table, calling table.withFields, which is my new list. And then obviously, as previously, I'm just formatting it, and I'm writing it back here to the same file. So let's run it quickly. Yeah, so running. Okay, it's done. Let's take a look at the VS Code. Yes, I have new field here. So that's how you can modify the code manually yourself once you know know what you have inside, once you know what you expect from the file. Okay. Let's move it and let's go to the next slide. But that's not the best way of doing it. Because if you have more complex file and you need to go there and you start modifying something that is much deeper in the structure, then, if you want to modify the field caption, which means that you need to create a new field. Because you have a new field, you have to replace the field in the list of fields of the table, which will give you a new list of fields. And if you have a new list of fields, then it means that you need a new table that will have a new list of fields. And then we have new table, but if your object contains multiple objects inside, not just a table, then you need new compilation unit that will replace the table. So, you're going up to the root. And if you're changing something really, really deep into the structure, then you might have a lot of complex code. So that's not really the way of doing it. So what you can do, you can use syntax rewriters. And what the syntax rewriter is, this is a class, a base class called syntax rewriter. And this class has a lot of methods, really, really lot of methods. And for each type of the syntax node, it has a method visit something. Yes, so we have visit table with the visit table field, visit page field, visit if statement, visit repeat statement, and so on. So every different type of node has this method, and those virtual methods, they return a node. By default, they return exactly the same node that was passed to them, but you can return a different node, and this node will be replacing the one for which it was called. So you can have, if you want to change something for a table field, for example, then you create your own syntax rewriter class that inherits from syntax rewriter. And the only thing that you have to do is to override this onVisitTable field method, which gets called every time a field is encountered in the syntax tree, and the field is passed to this method, and then you can create a new field based on this original one with some properties changed and return it, and then this field will be replaced. So let's take a look. Let's take a look how it could look like once we have the code. So let me just quickly open another example. So that will be update object with syntax rewriters. And I will have also the AL example for AL project that we can see. So open folder and project 2. So that will be our sample project. We have a table with 3 fields, and then our example Visual Studio project. Okay, let's quickly fix the path. So here, and here is our C# project. So this time I will be obviously reading all text. I will parse the source code as before, but this time I will create my new syntax rewriter, and then I will just call a visit on the root node from my syntax tree, and then which will give me a new root node, and then I will just format it and save it back to the file. And what about the syntax rewriter? Here it is. And as you can see, it inherits from the syntax rewriter, and it has just a visit field where it gets as a parameter my field node. So what I'm doing here, I'm just getting the name from the node, and then I'm creating a new caption property value using syntax factory again. Yeah, when I'm using the name of the field as the caption, then once I have the caption property value, I'm creating caption property, Yeah, so calling syntax factory dot property. First parameter is the type of the property or name of the property, and then the value that I created just here. Then I'm creating a new list of properties. So I have node.property_list.properties.add, which adds a new property to this one. And then I'm creating new property list. So this thing I need to create again. So here node property list with properties, which give me new property list. And then another call. Yeah, I need new node with new property list. So this is here. So what I created here, I'm passing here, and I have a new node. And then I'm calling the base method and returning the output from this method. So it should give me, then, if there is anything else that should happen, it will also happen because I'm calling this base method on a new node, yeah, the node that I just created here. So let's run it. Okay, it's running, compiling, again, running on another screen. Let's wait until it finishes. As you can see, I've finished. So let's take a look at the VS Code. And yes, I have captions. Yeah, so captions have been added. So that's how quickly I can add captions with very simple syntax rewriter. Okay, so that's this another example how you can modify the code, and this is really the way to go if you want to modify a lot. So that's how you can change those existing objects. What you can do if you want to change a lot of existing objects, how you can do it, how you can create your project, because those were just for example, how you can modify a single file. But if you need, complete solution, what you can do is to create a command line .NET 6 project, create separate syntax rewriters for every type of the change that you want to change. Yeah, don't create one big syntax rewriter with everything. Just create multiple one of those rewriters for every type of the problem that you're solving. And then go through all files from your project, and for each file, parse the file, get a syntax tree, and then use all your syntax rewriter one by one on every syntax tree that you're creating, and then save back the data to those files, and don't forget to format them. So just quickly, how it could look like. I'm not going to run it. I will just show you quickly how this complete solution could look like. Let me just open it in Visual Studio again. I will just show you the code, how it could be, what you could achieve, and you can create a command line tool just for you that you will be able to run and do a lot of changes at once. So it could be something that you may, if you want something that you will be running frequently on a lot of projects, then creating this kind of the solution could be a nice idea. So let me just quickly show you the code, what you can do. So obviously you can have a command line tool where you just expect a path to your projects in the first argument. Like here, I have just one syntax rewriter, but you can imagine that you can have more of them. So this is the same syntax rewriter that we had in the previous example. And then you can just get all files from the folder, and for each of those files, read the text, parse the file, then call visit on this syntax rewriter. Then if you have another syntax rewriter, then you can add it just below and call it on this new visit, this new root node for everyone that you have. And at the end, just format it and save it back to the file, and just tell the user, done. Solution has been processed and we're ready. So your project has been fixed or upgraded. That's how you can do it. Okay, so the last thing in this presentation, is about understanding source code, understanding the data types. And this is much more complex scenario, which sometimes you might have to use. So as I said at the beginning, syntax tree keeps the structure of your source code, but it doesn't have information about data types. This is only information about the structure. But there is another model. There is something called semantic model. And this model contains rich information about whole meaning of the program. And semantic model is compiled from every syntax tree in your solution and all the dependencies. But it knows the data types. And it allows you to match your syntax nodes from your syntax tree to operations and data types. So then you can travel whole your solution. You can check what it is. Yeah, you can check. Okay, this here I have a variable of this type, so I can go and check the type, and now I know what the variables, what fields this table, for example, has, or what procedure it has. And if there is a procedure, then you can know what parameters it has, what types of parameters it expects. Yeah, or you can have a bit of code that is calling the procedure, and then you can get information from where this procedure has been taken, what parameters it has. So if you want to know more about it, here's the link again to the C# Roslyn documentation. That's the information about using this semantic analysis to really checking the data types. Maybe not the problem, but not the issue, but okay, let's say issue that you may have here is that to build semantic models, you may need a bit of time. Not much, yeah, maybe a few milliseconds, maybe a few seconds. It depends on the size of the solution. But semantic models means that you have to compile your solution. So the compiler needs to load your data type, so all your dependencies, all your symbols, and then needs to go through every syntax tree. Yeah, so it needs to parse every file and then build a syntax tree and go to each syntax tree and compile the solution. So it's a huge difference compared to the previous example when you just parse a single file, modify what you can, and then save it back. Here you need to parse every file, even if you want to change just one. Okay, but let's just talk about the demo. Let's talk about the example. When you may need it and why you may need it. So let's open the example project and let's open the example example Visual Studio solution. So here is the example, and my Visual Studio is still opening the my Visual Studio project. But what we want to do, I have a procedure here with things that we should not be using anymore with statement. And I want to get rid of with. And obviously the question is how we can do it. Yeah, the problem here, the problem that we are having here is that to replace it, we need to find all the calls that are really calling as size header and replace it with size header.setRange. Yeah, size header.reset, again, size header.setRange. Yeah, here again, it's just findSet, or it should be size header.findSet. But here is a very, very interesting situation. We have another with just below. We have setRange. So those probably will be on the size line, but here we have a message. And if I hover, so you have sell to customer number, address, city, and here we have unit price. But some of those fields are coming from size line. Some of those fields are coming from the size header. And with just SyntaxRewriter, we don't know. Yeah, because I'm too with down, yeah, deep, 2 widths deep here, and should it be says line or says header, without really knowing anything about the data types, I don't know. And so seems to be a bit complex situation, but not if we use semantic models. So with semantic models, I have example here. I will load my project. I have this remove with SyntaxRewriter. This is my SyntaxRewriter, but this one also will be using the semantic model. So what I need to do is to I have some helper class here that is doing everything for me. This class will load all the syntax tree for me, will create the semantic model, and then I will use my SyntaxRewriter with one of the syntax trees that has been loaded by this class. I cannot load it again because the semantic model is built by this class on some syntax trees that has been loaded by this class. So if I load it again myself here below, then it won't work because that won't be the syntax tree which was used for building the semantic model. Yeah, it won't have all the links. So I need to take the syntax tree from things loaded by this class. But don't worry about it. Yeah, you can take a look at the source code yourself if you want and then see what's going on. So I have the semantic model, and then just running my SyntaxRewriter again, and then just formatting and saving it back. So let's take a look at this SyntaxRewriter. So what I want to do, I want to, for every identifier that I have, I want to check if it's something that needs to be replaced. Sorry. So for each identifier, I'm asking semantic model, hey, I have this identifier. What's it? What's this? And it gives me an operation. And then if it's really operation taken from semantic model, I can say, okay, what's the operation instance? So what is the owner of the operation instance? And so operation instance is like says line. That's the instance. Yeah, that's the owner of the operation. So if it's a field access, then the owner is says line. If it's the call, like procedure call, then the instance, the operation is call, and the instance or owner of the operation is says line or says header. And then, if that's the case, if I have the instance and it's part of I'm inside the with statement, then I will just add at the beginning the name of this instance. So says header, for example, or says line. Let's run it. Let's run it, and you will see the results. So just a moment, and we will have it.
In my eye on time, we have 6 minutes.
That's last slide. So we're there. I just want to show you the result. Okay, it's done. Yeah, we still have widths there because I don't have another rewriter that would remove them. But everything there, as you can see here, we have says header.res, it says header.setRange. We don't need this one, but again, would have to write more complex SyntaxRewriter. And here, as you can see, I have says line, and then I have says headers for other fields. So it's properly detected what's the owner or where's this instance of this field access operation is. So that's how it works. Now, that's all that I have. These presentations, I presented in on directions last year. So here's the link to the source code, because I know that there wasn't much time to explain what is happening. So if you want to really go deeper and see what this code is doing, go to this URL. Everything is there. You can analyze and go deeper and see how to write it. And that's all that I have. Yeah. So now I think it's time for questions.
Yeah. Great, thanks. Regarding questions, there are no questions in the question window, but maybe if somebody still has one, can step in. I had one question, but actually this slide answered it. Where can we find the code? And that's here. So that one is answered. So
you need this code. As I said, this last example was a complex one, and probably I would need, maybe half an hour to really go deeper into it. But then I would be afraid that it could be boring. So I just wanted to point you into the directions. Like you have syntax tree. There is something like semantic model. Here's the documentation from Roslin, and here is the example of the source code that is doing those modifications. So if you really want to do something yourself, just go. You can go to the source code and just take a look how it is done and just analyze what is happening.
Yeah, great. Thank you very much, Andrzej. I think, given that there are no questions, that we are going to close off for today. So thanks everybody for being here. Let me officially close off by sharing my screen. So we do have the last slides in view. So thank you everybody for being here. Might you have questions? Of course, use the recording. You might put a comment there if you have additional questions that are not answered enough by the recording. Andrzej, thank you very much for rerunning this presentation.
Thank you very much. Thank you for allowing me to do that.
More than welcome.